In today's video, we are going to add and subtract whole numbers using models. But first, we need to know what in the world is a whole number. Well, it is all your counting numbers plus a whole, the zero. So it's 0, 1, 2, 3, and keeps going. Now, addition and subtraction could also be called binary operations. Binary because you're going to have two numbers. When you combine it, you get a third number or another number. So now let's look at a few of the addition models for whole numbers. The first one is called the counting on strategy because we are going to be counting on from one of the numbers to another number. So we have 14 plus 3. So we're going to start at, let's start at 14, and we're going to count on 3 more numbers. So 14, 15, 16, 17. And then we stop at 17 because that's 3. So 14 plus 3 is 17. Now, would it be easier to start at 14 and add on 3? Or would it be easier to start at 3 and add on 14 numbers? Well, of course, it's easier to start at 14. So the key to doing the counting on strategy is to always start with the largest number. So look at this example, 7 plus 5. The largest number is 7, so we're going to start at 7, and then we are going to count on the next 5 numbers. So 7, 8, 9, 10, 11, 12. So 12 is 5 numbers past 7, so we counted on, and we ended at 7. The set model strategy you've probably seen before, maybe not looking this geeky, but you've seen it before, where you take 4 objects and you have 3 objects, and then you put them together and count them. That is the set model strategy. Now let's think of an example where that set strategy would not work well. And the key for it not working well is to realize when you do a union of 2 sets, if you have the same number in both sets, you only write it down 1 time. So in other words, here I have set A and set B. If I add those together in a union, I would have the numbers 1, 2, 3, 4, 5, and 6. Notice that I have 2 in both sets, but I've only written it down 1 time. So the cardinal number for A, set A, remember cardinal number is just how many are in that set. So there's 4 numbers in set A, and there's 3 numbers in set B, but if you look at the cardinal number for the union, it's only 6 because I didn't repeat the 2. So set models don't work well when you have repeated numbers. So that comes to our definition. We're going to let A and B be 2 disjoint finite sets. In other words, disjoint means they don't have repeated numbers, and finite, that just means they end. So when you have those two, those kind of sets, you can add those together. So when you do the 4 plus 3, those are called your add-ins, and the 7 is called the sum. Just as a side note, the plus first appeared in 1417 as a short way to write in what stands for in Latin is and, the and symbol. So, so it came about in 1417. Let's look at the number line strategy, our last strategy. We're going to use arrows to represent 4 plus 3. So the first thing you're going to do is start at 0 and go out to 4. Notice I then stop the arrow, and then I begin it again and go 3 more places to the number 7. It is perfectly fine to do humps. A lot of people like to do humps, and that's okay. We're going to start at 0 and do our humps, but you've got to label it and stop at 4, and then you would do 3 more humps. Again, you've got to label those humps and say you're going to be at 7. So either one is fine. The number line below shows a very common mistake made by students. So I want you to figure out what that common mistake is and turn it in class. Okay, now let's talk about using the number line to order whole numbers. So that's trying to figure out which one is smaller and which one is larger. So notice that 4 is to the left of 7. So we say that 4 is less than 7. So the math way of writing that is with the less than symbol. Whenever you're using less than or greater than signs, remember the alligator is always eating the big fish. Notice 7 is bigger than 4. So the alligator is eating that big fish. It's also true that 7 is to the right of 4. So we could say it's greater than. So we have our math way of writing that. Is the alligator eating the big fish? Yep, see the 7? The alligator is definitely still eating our big fish. We can also say less than or equal to. So there's our less than or equal to. There's our greater than or equal to. So look at the statements below. All those 1, 2, 3, 5 statements. What do you know about those 5 statements? Compare those, and you're going to tell me in class.